you're told that this entire solid is 28 centimeters, and the radius of each of those solids of rotation is 3. Okay, well, if that's 3, then that means that the height of this cone is twice the radius, or 6. So from here to here is 6 units. Okay, and if this hemisphere down here also has a radius of 3, this length of 3 is the same whether it's here or here. So even though these two segments are different lengths, they represent the same length. So all of these are radii of 3, which means when I draw from the middle straight down to the end, that's a distance of 3 as well. So from here to here is 3, giving you a total of 9 for the outsides, and that leaves 28 minus 9 for this cylinder, and that gives you 19. And once you have those measurements, you can now solve for the volume of each one independently. So the volume of the cone is 1/3 BH, where B is pi r squared. And so if you calculate what you have here, the radius of 3 times the height of that is 6. So this 3 cancels with one of those 3's. You get a total of 18 pi here. Okay. In the second, the cylinder is going to have a total volume of capital B, capital H, or pi r squared h, where the radius is still 3. This one has a height of 19. And so when you calculate this, you have 9 times 19, which is 171 pi. And then finally, the very last, the hemisphere, has a total volume that is half that of a corresponding sphere, 4/3 pi r cubed. Again, the half and the 4 cancel. You get 2 pi times the radius of 3 cubed. And this was all over 3, so 2/3 of pi r cubed. So this 3 cancels with one of those 3's. 3 squared is 9 times 2 is 18 pi as well. And so your total is going to be the sum of all of these. If we add those together, we get 171 plus 2 18s, which is 36, giving us 207 pi cubic centimeters for our exact answer. And if we were finding the approximate answer, we could put this into a decimal form. Oops. 207 pi, written as a decimal, is 650.31 approximately.